Can you all able to see the screen?
Yes, we can.
Okay, okay then. Okay, let's start the lecture for today. I would like to introduce myself. My name is Asif Iqbal, uh, and my specialization is on security in computing. And I graduated from University Putra Malaysia from Malaysia. Going further into the topic for today. You all heard about operating system, and we have been using operating system for a quite long time. Before we go inside the topic for today, let me ask you, what is your understanding about operating system? Of course, in our day-to-day life, we have been using operating system. Many of the devices that we use have an operating system, means a software or a material which operates the entire hardware component. Okay, for example, consider the human body. What is the operating system of the human body? What is the operating system of the human body?
The organs.
Or organs or devices? Organs or devices? I am asking, what is the operating system? Means the material or the thing or a specific aspect that drives the entire organs. What is it?
Brain.
Maybe a blood.
No. What operates the entire human body? What operates the entire human body?
Harga motornya enak, pada kita kan bergerak gitu kan.
It is brain.
Nerves.
Motor itu belah kaki bergerak lah itu.
Hello, can you unmute when you're talking? I can hear background noise. Okay.
Brain,
Now,
sir.
brain is one of the device in the human system. Brain is one of the device. I'm asking, what drives the entire human body?
Is it nerves?
It's hard.
No, nerve is also one portion of the wires running, connecting all these organs. But what drives the entire human body?
Is it the brain?
Brain is one of the device. Okay, let me come to the point. What is the portion, what is the operating system of the body? Is our soul. The soul inside. When the soul leaves the body, we call it as death. Is that clear? When the soul leaves the body, every device comes to the state of rest. When soul come inside our body, we are able to do actions, right? So means that the soul in our body drives the entire human body. Do you agree with me?
Yeah, I agree.
Yes, sir.
Yeah, we understand.
Yes, the soul is the most important part. When the soul is inside our body, we are able to do the things we want. When the soul goes out of the body, automatically everything comes to a state of rest. Likewise, an operating system for a device, not only computers. Today we have a lot of smart devices. We have a lot of smart devices, and every smart devices needs an operating system, right? And then when the operating system is the one which controls the hardware components of the devices, instead of once upon a time we give a definition as such, right? When operating system is a software which drives or which controls the entire computer. But now it's not only computer, we have a lot of smart devices available today. So today an operating system is a piece of software like a soul for a human body, which controls the entire hardware components and make them to interact with each other. For example, my body and my voice is in sync, right? What my brain thinks, my voice, my mouth exposes. Similarly, all these coordination matters are taken care of the operating system. Let us go into the stuff of today. Okay, operating system, when we hear about operating system, we call it as old stuff. No, operating system is since from the very beginning of the inception of computers, but it's not old stuff. Why? Because they keep on growing. Yesterday, the operating system that we use is different from the operating system that we use for today, right? Previously, we use a different kind of operating system, right? And once upon a time, the nature of the devices that is installed in a machine is lesser. Today, we are able to connect to a lot of devices with our machines. So meaning to say that the way that the operating system operates today is different from how they operate yesterday. Only thing is, it's not an old stuff, it is a new stuff because it's a growing stuff. When something keeps on growing day by day with new things and adapting to new things, automatically it is no more a old stuff, it is a growing stuff. For example, we take our human body. 20 years before, the skill that is needed for survival is different from in 20th century. The skills that we need for survival is different. Of course, what our parents have skill is different from the skill that we have. Means that again the soul is the same, right? What the soul that our parents have is similar to the soul that we have today. Only thing is, we have come up with an extra skill where the previous generation did not know about. Means that the operating system is something which keeps on growing day by day. So when we look at the operating system which we used yesterday, 20 years before, is very lightweight, right? Cannot do many things. But today the nature of the skill that an operating system has is different from what we have yesterday. So remember that operating system is not a old stuff, it is a growing stuff, right? Maybe 10 years later after this, we may have an operating system that may be able to communicate directly with satellites, maybe in the future. But today, it are smart devices. We have IoT, right? We have many things that we have connectivity with. That how we are dealing with devices today. So what we have to understand in our mind is some things never die like operating system. They just grow, means keeps on improving, adding up new things and adapt to the changes of the environment. Probably after CMCO, we have come to understanding that there are many online tools which help us to move towards each other, right? That is the new learning that what CMCO, the pandemic, give to us. All because the basic soul operating system keeps on improving, right? And coming to the next point, well-known OS functions, right? Well-known OS functions. These are the common things that every operating system records. One is file system, scheduling, protection, network communication, and reliability. What is file system? Probably consider I am delivering a topic to you, right? Depending on your understanding and interpretation, every one of us record this information in our brain in a way that we are able to understand, because that is file system. File system is a way an operating system records a data on the bare hardware device or memory, whichever you call. For example, here in your case, right, I'm delivering a lecture, right? I'm delivering the same thing to everyone, but every soul records the information in a different way that the soul is able to understand. Similarly, every operating system has a different way of recording data. Every operating system way of recording data, right? That what we call it as file system, right? Every operating system has a different file system. Scheduling. What is scheduling? Scheduling is managing task, right? I have 4 things to do. I need to know which one to do first, which one to do second, which one to do third. So I am managing between tasks. And the next is about protection. What is protection? Protection is primarily to support effective but controlled data sharing, right? When we have how much it could be exposed, right? For example, in a social media, everything is exposed, and but we have a kind of privacy concerns where we limit what we can allow others to do. That you call it as protection. Here, in the case of operating system, right, we have a criteria called protection, which will help the amount of data that could be exposed to others. Protection, in other way, we call it as security, right? The next one is network communication. Communication is the ability of a device to communicate with another device. That's what we call it as network communication, right? The operating system provides the support for one device to communicate with another device, right? Next is reliability. How much we could believe, right? Consider we are giving a task for an operating system to do something, right? When we allow them to do something, how much we could believe the answer given by them. That is called as reliability, right? Somebody tells something, how much we could believe it, right? So reliability is the ability that we could rely or believe on the data. Okay, coming directly to the topic for today is process scheduling. Process scheduling is an important aspect of multi-programming. What is multi-programming? Dealing with multiple processes at the same time. For example, the instant of time when I am talking to you, I am looking at you. I am hearing you, right? If you stop my lecture and tell something, I may be able to hear. Means that at the same time, I am able to see, talk, breathe, and hear, right? Multiple programs running exactly at the same time, right? So when we say that multi-programming, we have 2 things. One is input and output. Another is processing. How we divide it? Input is what I talk to you, and what you talk to me is again input, right? What is the output? Output comes after processing. Consider I deliver a lecture, and after that I give you an exercise to complete, right? So the output shows that how much do you understand the topic. So probably in a device there are 2 things that need to be scheduled. Number 1, the input and output, when to receive the input and when to provide the output. The next is processing. Processing means which process has to be given a priority to complete first. That what we call it as process scheduling, right? So here what we are going to talk about is process scheduling. What are the goals that we have to achieve? One is high processor utilization. Means that when a particular resource is free, we need to make the best use of it. How to make the best use? It is not left free. At all the time, it is given a task to complete. For example, like we people, if we don't have tasks to do, we become lazy, right? So every process, every device is given a certain amount of process to keep on active at all the times. So the plan number 1 is how to utilize the resources available. Okay. Number 2, throughput. Number of process completed per unit time. Consider I'm giving 4 exercises. right? Some of you may be able to complete all the 4 exercises in 30 minutes time, and one of you is able to complete in 10 minutes time. Some of you is able to complete only one exercise in 30 minutes. So probably that is your throughput. Throughput is the ability of the processor to complete a process, right? So maybe it depends, it differs from person to person. I may do something in 10 minutes which will take 20 minutes for you to do and 35 minutes for another one to do. So that is our throughput. Throughput is the amount of time that we are going to use in order to complete a task. Next is low response time. For example, I ask you a question and you want to tell the answer. How much time do you take in order for you to answer my question? Consider I give the question, the next second you are able to give the answer. That means you have 0 response time, right? I ask you a question, you take another 10 to 15 seconds to reply back to my answer. For example, I tell Assalamualaikum, the moment I say it, you immediately reply back to my salam. That's what is it? Is it 0 response time? But other case, I ask you a question, you may take more time to answer the question. So that's how we tell it as response time. So 3 things are major for process schedule. Number 1, processor utilization. You must make use of the processor at all times. Number 2, throughput is the ability of the processor to do a process. That means how much time it consumes to do a process. Low response time is how much response time, means that when a process is given, how much time we have to wait to get the answer. Okay, so the topic for discussion is we are going to learn the fundamentals of process, types of scheduling, short-term scheduling, and various scheduling criteria. And we are going to discuss about 3 algorithms: first come, first serve, round robin, and shortest job first. These are the 3 algorithms that we are going to learn today for this morning session. Let me move on. The cycle that we have to know is CPU and input-output cycle. CPU is the processing unit. I/O is the input and output, the time waiting for the user to provide input and the time the output get displays on the screen or the printer. Okay, we observe the process require alternate use of process and I/O in a repetitive fashion. For example, each cycle, if you tell one cycle, we have CPU burst followed by I/O burst. Burst is the amount of time. For example, processor process for 5 milliseconds. And then input output burst usually longer, right? The shorter should be the CPU utilization time. Okay, a process terminates on a CPU burst. We start and at 1 millisecond and we complete it at 5 milliseconds. Means that a CPU burst is the amount of time the processor has been utilized. For example, in this case is 5 milliseconds. Okay, to understand better, you can look at the diagram, right? The first one is CPU burst. Some case here, if you look at this, the amount of time a processor is utilized, this is longer, right? Shorter here is the waiting time, right? The rectangle that you see is the CPU utilization time, and then the straight line is the waiting time for the input on our output to respond, right? So every cycle will have CPU utilization and waiting time for input and output. So we call it as CPU bound process and IO bound process. Means that CPU bound is something is under process. We are waiting for the process to get completed. That is CPU bound process. Means that the process is processing, we have to wait. IO bound process is that we are waiting for the user to provide the input so that you can start the process. So that is the waiting time, right? CPU bound process is the utilization time. IO bound process is the waiting time, right? Okay, consider the programs with the processing component, right, and IO component indicated by uppercase and lowercase. So the processing component is A1 and the smaller number is the IO component. So A1, we start a process 0, 0 until 30. This is the CPU burst, 30 milliseconds. After that, we have a waiting time from 30 to 50, means that 20 milliseconds is the waiting time. Clear? A1 is the CPU burst, right? It starts at 0 seconds. It starts at 0 second and finishes at 30 seconds, right? So the CPU burst time is 30 seconds. And then A1 is we are waiting for the input or output to respond. So if you look at in between 30 to 50, we have 20 milliseconds. So means that 20 milliseconds is the waiting time. Again, if you come to the second CPU burst A2, 50 to 80 is how many seconds? Is 30 seconds. 30 seconds. 30 seconds is the CPU burst, and after that we have a waiting time of 40 seconds. If 80 to 120, you can see here 40 seconds is there. 40 milliseconds means that you need to wait for 40 milliseconds for the input or the output to respond. Again, you go for A3, 120 to 130 means that the 30 only 10 seconds is the process and the job is completed. Consider a job consists of several CPU bursts, right? Like when we want to complete a process, we need to take step 1, step 2, step 3, step 4. Similarly, every job have several CPU bursts. A1, A2, A3, which is in capital letter, is the CPU burst time, right? A1 and A2, which is in small letter, is the IO waiting time. So sometimes the CPU burst time is more. Some cases the waiting time is more. Coming back again, you can take another process. Why we put A, B, C, right? A is job A, B is job B, and C is job C, right? So in job B, you can see here, B1, it starts at 0 and then go until 20. 20, you have 20 seconds for the burst time, and again waiting time 20 seconds. You can see here for B1, 20 to 40 is 20 seconds. Again, B2, 40 to 60, 20 seconds burst time, and the job is finished. Because it's a smaller job, it requires only 2 CPU cycle. Only requires 2 CPU cycle, means that 2 steps to complete the entire process. Job A requires 3 steps to complete the entire process. Likewise, come back to the job C. Job C requires 5 steps. C1 capital letter, C2 capital letter, all or the CPU burst time. And the small letter, which is in red color, is the IO waiting time. So for C1, you can see here, we have from 0 to 10, we have 10 milliseconds. And then after that, we wait for 10 milliseconds. Again, we start at 20, and then we take another 40 milliseconds. 40 milliseconds to complete the process. So what we need to remember here is, based on the example given, the CPU burst time and the IO time are different. Number one, it is different, right? Sometimes the CPU burst time is higher. Sometimes the IO waiting time is higher. It may differ. Not necessarily all have to be the same, right? So sometimes the waiting time is more. Sometimes the burst time is more. Sometimes you take more time to process, right? Sometimes you have to wait more time to provide input. So there are cases. So we need to understand that a process consists of several cycles, right? It is divided into CPU burst and IO burst. CPU burst have a specific time to complete and IO time have a waiting time to complete. So when we say cycle, it includes CPU time and also input output time together. Is that clear until here?
Yeah.
Hello. Okay. Let
Sir,
me
may I
pause.
ask something?
Okay. Okay, coming here, the starting time and ending time of each component is indicated below the symbolic references. So A1, the uppercase letter is the CPU time, and the smaller letter is the waiting time. So, and now we consider the three scheduling criteria. This is the scheduling criteria which we learned in the previous slide. CPU utilization. Keep the CPU as busy as possible. So don't waste the resources. Keep on using it all the time. And next is throughput. The number of process that can complete their execution per time unit. For example, if I give you 30 minutes time, what you could do, right? In 30 minutes time, one of you can complete one exercise, another one will complete 2 exercises, another will complete 3 exercises, another can complete 10 exercises. So that is your throughput, means that the amount of work that could be completed in a given duration of time. Turnaround time, amount of time to execute, right, to complete a particular process, right? For example, task 1 needs 30 seconds, task 2 needs 45 seconds, task 3 needs only 3 seconds. So means that the amount of time that is required to complete a process, that you call it as turnaround time. Waiting time is when one process is underway, that we have to wait in order for it to complete so that we can proceed with another process. So the amount of time that we have to wait to complete. For example, when we start the today class, we have been waiting for around 10 minutes time for every one of our friends to join the class. So it means that it is a waiting time for all of us. It's a waiting time for all of us. The moment I start the Zoom session, immediately many of you have joined, right? So since the time when joined, we have been waiting for others to let them join. So that is the waiting time for each of us. That means our process is waiting. Me, a teaching process, is waiting for me, for others to join so that I can initiate the teaching process. You all waiting for your friends to join the sessions so that right, you can initiate your listening process. Okay, so response time, the amount of time it takes when a request was submitted and the first response is produced, right? For example, when I ask a question, probably everybody know the answer, so but everybody take a different time to give the answer. Someone immediately can, someone after 2 seconds you know the answer, after 10 seconds, after 20 seconds. So the response time is the amount of time that has been taken by a process to respond back, that you call it as response time. Okay, there is 3 types of scheduling: long-term scheduling, medium-term scheduling, and short-term scheduling. Long-term is to add the pool of process. Maybe the list of process to be completed is bigger, right? Medium-term, to add the number of process that are in the main memory. Medium-term process usually will be executed in the random access memory. Short-term, which available process will be executed by a processor. Short-term. So we divide all the process into long-term process, medium-term process, and short-term process. To decide which process pending IO request shall be handled by an available IO device. So Actually, the input-output scheduling is depending on the availability of the input device and the output device. For example, at one particular time, I can talk about only one topic, not two topics at the same time. And then at one particular time, you may hear only one thing. Even we may have 2 ears, but we are able to hear only one thing at the one time because input and output devices are as such. Moving on, this is how. These are the states, right? For long-term scheduling and short-term scheduling. Long-term, which process to admit we have to decide, right? Medium-term, which process to swap in or out. Maybe like if it is smaller process, I think we can in and out. Short-term, which ready process must execute next. If you look at this diagram, you can see here a new process is coming in, a new process is coming in, and it is ready. And when it is ready, right, it goes to a return state, then we call as medium term scheduling. After it is ready, it is sent for running, means that it is executed. You plan something and you start doing that work and it is completed. When it's one term like new, right, a new process, it's ready and then ready to go in and it finished, completed, exit. This is called as short term. You can see here short term scheduling. Short term scheduling means it only requires very less amount of time to complete. Very less amount of time to complete. And then later after this you have another state. This is medium term. New, ready, maybe it has several cycles to complete. So what we do, we suspend and then block for some time and then again ready and it keeps on running. Again, long term and short term depends on iterations, right? If we have only less cycle, 2 cycle, 3 cycle, then it is medium term. If have too many cycles to complete, again the process is the same. New, ready, running, exit. Right? This is the 3 things. Exit only happens only when the entire process is completed. You remember that? Other than that, new, ready, running, block, again suspend, and then again ready, suspend, and ready, and then again running. So means that there are several cycles. So to understand it better, we take it like this, right? A short term process needs only one cycle. So when it's ready, it goes for execution and it is completed. A medium term have several cycles to complete. So it goes and utilizes the CPU, and after that it is suspended and again it gets ready and execute and finish. This is medium term. Long term is it takes longer number of CPU, means that it has to do several cycles in order to complete. To understand it, right? Some of the process we do have only one step. Some of the process we do is have 2 steps or 3 steps. Some of the process we do have 10 to 15 steps. So the one which is having lesser steps is short term, right? Medium number of steps is medium term, and more number of steps is long term. Okay, here you can see here, I have given the CPU burst time. For example, in first come, first serve basis. First come, first serve basis. We have 3 process which is arriving at the same time. Process 1 needs 24 milliseconds. Process 2 needs 3 milliseconds, and process 3 needs 3 milliseconds. So process number P1, P2, P3 is given depending on the arrival time. The one which arrives first is process 1. The one which arrives second is process 2. The one which arrives third is process 3. So process 1 needs 24 milliseconds. Process 2 needs 3 milliseconds, and process 3 needs 3 milliseconds. So here you can see in the Gantt chart how we do it is, right? First, we admit process 1. After process 1 is completed, 24 seconds, we give it to process 2. And later, we give it to process 3. How we calculate waiting time? So for P1, there's no waiting time. Once they come in, it is served. So 0 waiting time. For P2, in order for P2 to get served, it must wait for 24 milliseconds. So the waiting time for process 2 is 24. Right? For process 3, it needs to wait for 27 milliseconds. Why? Process 1 must complete first, process 2 must complete second. So 24 plus 3 is 27. So the total waiting time to complete the process for process 1, 0, because it is come immediately or it is served. And for process 2, it is 24. For process 3, it is 27 seconds. So 24 plus 27 is and divided by 3. So the average waiting time for this job is 17 milliseconds. So 0 plus 24 plus 27 divided by, because we have 3 processes, so we divide it by 3. So we got 17 minutes. 17 milliseconds is the average waiting time to complete all the process. Is that clear?
Yes, clear, sir.
Okay, fine. I will move on to the next scheduling. Okay, first come, first serve. This is first come. Again, you can see here, we put it in a different order. Process 2 comes, P2 comes first, P3 second, and P1. We change the order. Just, I don't want to change the numbering. I just change the order. P2 comes first, P3 comes second, and P1. For example, you can see here, P2 have only, as you know, P2 has only 3 milliseconds, needs 3 milliseconds of time. P2 needs only 3 milliseconds. P1 needs 24. So what we do is, right, if it arrives in a different time, so P2 arrives first, so we give for P2. Then P3 arrives, we give for P3. Then only P1 arrives, so we give P1. So you can look at here, P1 has a waiting time. P1 has a waiting time only 6 seconds. You see here, P1 have only 6 seconds, so 0 until 6. P2 have 0 because once it comes, it is given. And P3 has only 3 milliseconds. So when we calculate the average waiting time, 6 plus 0 plus 3 slash 3, the waiting time is only 3 seconds. So the point is that if the bigger process comes at the beginning, the waiting time is longer. If smaller process comes at the beginning time, usually the waiting time is lesser. That we have to understand from this, right? If bigger process comes first, then waiting time is longer. If the bigger process comes last, the waiting time is very lesser, right? That's what we have to understand from these 2 examples. The next is shortest job first, right? Shortest job first, right? So here in shortest job first, we have 2 modes: preemptive scheduling, non-preemptive scheduling. One CPU given to the process, it cannot be preempted until it completes an entire CPU burst. Preemptive means that how big the process is, when it is allocated to the processor, it will finish until completion. Then only we will move on to another process. That is non-preemptive. Preemptive is if the process is longer, we divide into smaller pieces. So one portion of the process execute first, and then later we give it to another process, and then again we brought forward the first process, again we give another process, again we brought forward another process. To understand it better, consider, I am telling you, I have finished my lecture. Do you have any questions? Consider, for example, Nabila have 10 questions, right? And then Muhammad have 5 questions, and Rahmia have only 1 question, right? So but Nabila want to start first. Nabila asking me the first question, and then after I answer the first question, again Nabila asked the second question. So I cannot wait until Nabila finishes all the questions and then I move on to the next one. Then it is non-preemptive. You understand? When I were to complete all the questions of Nabila and then only I can continue with Muhammad, then it is non-preemptive. Instead, what I do is first question from Nabila, I answer. And after I go for the first question for Muhammad, later I go for the first question for Sarah, right? Likewise, if I go in a fashion that one after the other, then it is preemptive. So either a scheduling can be preemptive or non-preemptive. I can complete one set first and then go on to the second one, then it is non-preemptive, right? So the if I'm going to answer all the 10 questions of Nabila, so Muhammad have to wait until I complete answering. Instead, I finish one Nabila's question and go on with Muhammad question. That is preemptive. Is that clear?
Yes, clear,
Okay.
sir.
Okay, the last time is shortest remaining time first, right? The process which has completed major portion of the process and have lesser time needed, then we will give priority to that. These are the way that we handle shortest job first. Let us go on to the example. We have process 1, process 2, process 3, and process 4, right? Here we divide into non-preemptive. Non-preemptive means we need to complete one whole set before we moving on to the next set. So process 1 needs 7 milliseconds of burst time. So we complete process 1 first. And then we move on with process 3. We move on with process 2. We move on with process 4. This is how it happens, right? This depends on the arrival time. If you look at that, P2, P1 arrives first, followed by P2, followed by P3, followed by P4. So if you look at that, as we mentioned, process is shortest job first. That's why if you look at the diagram, after process 1, process 2 is not executed. Process 3 gets executed. Why? Process 3 has the shortest time. Now the question comes, sir, but process 2 arrives first. Process 2 arrives first before process 3. But you look at process 1. Process 1 is doing for the first 7 milliseconds. Process 1 is doing for the first milliseconds. While we are entertaining process 1, all the other processes has already arrived. Is it clear? While we are trying to complete process 1 for 7 milliseconds, all other processes have already arrived in the system. So now when we were to start the next process, process 2 is already there, process 3 is already there, and process 4 is already there. So out of these 3 processes, we have to choose the smallest job. So out of these 3, the smallest job is P3. That's why we complete burst time is only 1 milliseconds. So that's why we give priority to P3 first, and then we go with P2, and then we go with P4. Is that clear?
Yeah, clear.
Okay. So if you look at the average waiting time for P1 is 0, P2 is 6, and P3 is 3, and P4 is 7. So divided by 4 process, you have only 4 milliseconds waiting time. This is for non-preemptive. Now we go on preemptive. You have a different thing. Okay. For preemptive, if you look at it, process 1, process 2, process 3, process 4. Similar, we use the same one, but here you look at it, right? Process 7 needs 7 milliseconds of burst time. But what we do is we try to divide into equal slots. We already divided, right? 2 burst time per slot. Remember that? 2 milliseconds burst time per slot. So that's why you can see we divided 2 milliseconds. So process 1, we give only 2 milliseconds. And after that, we go with process 2, 2 milliseconds. Then we will go with process 3. But process 3 requires only 1 millisecond, so it's finished faster. So then we give another 2 seconds for process 2, right? And again we give another 4 seconds for P4, and finally we go for P1, right? You can see here this is shortest job first, right? This is the shortest job first. So P1 we give first time, right? So 2 is completed, so 5 is balanced here. And process 2, again 2 is completed, 2 is balanced. And process 3 is only 1, so we finish it first, right? And then we go for process 2, because process 2 has a lesser time, only 2 seconds, only 2 milliseconds. So that's why without touching process 4, we go immediately to process 2. Why? You can see here, you can see SJ shortest remaining time first. When we have less remaining time, we must give priority to that first, even though it's preemptive or non-preemptive, right? When we have lesser waiting time, we must give priority to that first, so that it can be completed faster. Is that clear? The reason why we give process 1 first, process 2, process 1, process 2, process 3, and again we give it for process 2, because process 2 have lesser waiting time, because only 2 is left out. But for process 4, 4 is almost left out, and process 1, 5 is left out. So we give priority to P3 first, so that it gets completed first, and then again we give to priority to it complete first, and only left out only 2 process. Why? Our concern is to reduce the waiting time for everyone. It's not only for one process. Our concern of the scheduling algorithm is to reduce the waiting time for everyone. So that's why we serve those process which has less remaining time. Is that clear? Hello, are you with me?
Wait, sir, I'm trying to understand.
Okay. No, it's very simple. Process 1, process 2, process 3. Process 1 needs 7 milliseconds burst time, right? So first thing, in a preemptive, we cannot allocate the whole time to one person. Like I cannot keep on answering one's questions, right? And Nabila is asking 10 questions, so I don't wait until I answer 10 questions. Instead, I answer only 2 questions of Nabila. Later, I move on to Muhammad, and after I move on to Adinda, and later I move on to the other, right? So I don't want to allocate the entire time for one person. But at the same time, I'm keeping in mind, if someone have lesser number of questions, I need to serve them first, right? So first, P1 I serve first, right? And then after I go with P2, and later I go with P3, right? Immediately, suppose I need to go with P4. Why I am not going with P4? Because P4 have 4 milliseconds to be served. But then if you look at P2, we already served him 2 milliseconds, right? So left is only 2. Left is only 2 for P2, and left is only 5 for P1. So that's why I choose the less remaining time. P2 has less remaining time when compared to P4. So I serve P2 first. Clear? And then later when we compare P4 and P1, P4 needs only 4 milliseconds, where P1 needs another 5 milliseconds. So I serve P5 first, and later I move on to P1. Later I move on to P1. So the amount of waiting time for a particular process to get completed becomes lesser. That is the basic idea. We don't want everyone to wait for a longer time to get served. That's why we trying to schedule in such a way that there will be only lesser time, waiting time for everyone. So you look at here, average waiting time. Average waiting time for P1 is 9. Why? You look at it. P1 until it finishes. You can see here, that is the waiting time. First, P1 is served until the 2 milliseconds. From 2 until 11, from 2 until 11 is 9 milliseconds. That's why we put P1 completes after 9 seconds. For P2, how much time it waits? P2 waits for 2 milliseconds, supposed to be. It's supposed to be 2. And P3 is no. Why P2 we put 1 is because only after it arrives at 2, right? So it waits just only for 1 minute. And then for P3 is 0 waiting time. And for P4 it is 2 minutes waiting time until it arrives. So here this is how we calculate the waiting time, right? So you can use this kind of diagram so that you will be able to complete it. So P1, why 9 is like, consider P1 arrives here. It is served immediately for 2 seconds. From 2 until 11 is 9. P2 until 11 is 9. And then for P2, here you can see here it arrives at 2, right? It arrives here. So only 1 minute it has to wait. And then for P3 arrives only at 4. So 0 waiting time. It arrives only here. So when it comes in, immediately it is served. So it has no waiting time at all. You must check on the arrival time as well, right? When calculating it, you just not only check on this graph, you also check on when it arrives, right? If it arrives later, when immediately it is served, that means there is no waiting time. So accordingly, you choose the number for this. Okay, the last one is round robin. Round robin. Each process gets a small unit of CPU time, usually 10 to 100 milliseconds. And after the time is elapsed, the process is preempted and added to the end of the ready queue. Means that I serve, for example, if you take Nabila having 10 questions, after I answer one question, I move on to the next. So after I complete answering all other questions of other students, then only I will move on to Nabila's second question. So it means that every process is given a fair chance before the one with more amount of workload has been served. That is the point of the round robin. Means that everybody is allotted time. Okay, I will allow you to ask only one question. Means that I set time frame. I set the number of questions you ask. Okay, can you ask your first question? Can you ask your second question? Can you ask your third question? I go question by question rather than by student. Okay, coming here in the round robin, the quantum is 20. Quantum is the time frame. Given time quantum is given is 20 seconds, right? 20 seconds, right? 20 milliseconds, not seconds, 20 milliseconds. So process 1, process 2, process 3, process 4. You can see here. Burst time for process 1 is 53 milliseconds, process 2 is 17 milliseconds, process 3 is 68 milliseconds, and process 4 is 24 milliseconds. So how we do that? We first serve process 1 20 seconds and process 2 another 20 seconds. Because process 2 is only 17 seconds, it completes earlier. So we have 3 seconds. So we start again immediately. Process 2 finishes. We continue with process 3. And again, we continue with process 4. Again, we start process 1 after we complete process 4. So every process is given their own share of time until they finish completing. If you look at it, process 3 has the largest burst time. That's why process 3 finish last, right? The one having a longer time or a bigger burst time will finish at last. Okay, coming to the summary. Here, scheduling is important for improving the system performance, right? Methods of prediction play an important role in operating system and network functions. Why? We need to allocate time for everything. So scheduling is about how we allocate or allot or reserve time to do a particular process, right? Simulation is a way of experimentally evaluating the performance of a technique. Probably you have simulation for all these algorithms available online. You can try as well, right? And then in the next class we'll see about the other things, right? And coming to the next one, now it's the time for you to do hands-on, right? I will move on for you to screen capture this site. So as example, let me move on. Okay, can you screen capture this slide so that easier for you to work out the exercises? Screen capture this slide. Done. I move on to the next slide. Screen capture this. Done.
Done.
Okay, I'll move on to the next one. This one is for non-preemptive shortest job first. So once you screen capture, you save as well. If you forget to save, then I think everything is gone. Every time you screen capture, you save it in a document file or so that you can refer when doing exercises.
Done, sir.
Okay, next.
Done, sir.
Round robin.
Done.
Okay, now this is the exercise for today, which you have to complete and upload in Google Classroom before the end of the class. Done? This is for first come, first serve. Huh? First come, first serve. This one is for, again, another one example for first come, first serve. Screen capture.
Done, sir.
Next, shortest job first. Okay. Okay, now feel free to ask me questions. Later you can start with the exercise, right? And then I will share the Google Classroom code. Probably Mr. Ahmad Pitra will send you in your group. Huh? You have a separate group for this class, right?
We still don't have a web.
Do you have a separate group for this class, right?
No, we don't.
So
we have the group mixed with all the students.
Okay, but still you can be reachable because we know this is for today's class. Of course, the one who are attending today's class will know about it, right?
Yeah.
Okay. It's okay. Okay. Now, or I will give it now itself. No problem. I will share in the Zoom session as well. You just can copy and keep it, right? So when the Zoom session closes, automatically the data will be lost. So what I suggest is I will share it in the Zoom session itself so that you can copy and paste it somewhere so that later you can use the code to upload your answers. Correct?
Okay, sir.
Okay, now, as of now, what you have learned is about process scheduling. You learn 3 types of process scheduling. The first one is what? First come, first serve. First come, first serve. The next one is shortest job first. In shortest job first, we have 2 modes. One is preemptive, and another one is non-preemptive. Preemptive and non-preemptive. Right? And then the last one is round robin. Remember that in all algorithms, we need to remember, we also have to keep in mind that the process which have shortest waiting time, right, our shortest burst time should be served first, right? So that we keep in mind, right, when only you have 10 process, you have already completed with 8 process, only 2 is left out. Which to serve first, you must decide how much time it needs. The one which needs lesser time should be served first, then the one which needs longer time. Okay. Any questions for today's class? Maybe in the afternoon session we will discuss about a different topic. For the morning session, any questions? Feel free to ask. Feel free to ask any questions.
I think no question, sir.
No question. Is it everything clear? Can you all open your video so that I can capture a picture for today's class? Can you all open your video, please? Angita, Ilyas, Hafiz, Rahmialis, Nabila, Zikrilla, Noviana, Arinanda. Okay, smile please. I think everybody feel like very stressed, huh? Morning time, huh? Smile, 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 please. Allah will ease all our life. Okay. Okay, thank you very much for joining the class today. See you all again afternoon, huh? Okay, by the time what I suggest you is, wait, let me give you the Google Classroom code, so easier. I will give you the Google Classroom code so that you will be able to give. Hold on, I will give. Okay, I am posting the Google Class code in the Zoom session. In the chat session, you look at it. This is the Google Classroom code. Can you see it?
Where is the code, sir?
We
I just
cannot
posted.
see any code.
I just posted. Can you see it?
No, we cannot see it.
In the chat, I posted the code.
Gak ada, Pak.
No, it's nothing.
Wait. Everyone in the meeting. Okay, now. Can you see now? OB.
Yeah, we can
Let's
see
see.
it.
Udah, Pak. Udah bisa.
Yeah.
Yes, sir.
Udah bisa.
Okay. So inside this Google Classroom, I have created a classwork called Exercises Morning. So you can upload your answers. How you are going to upload? Try to work out for all the questions which I give on a paper, right? You have already screen captured, right? The samples and also the questions that you have to answer. What you do? You do it on a paper, right? And after that, using your mobile phone, WhatsApp, or you can copy, or if you want to do directly in Microsoft Word also can. It's up to you. If you want to work out on the paper, just screen capture and paste it inside the document, and then put it inside the Google Classroom. Right? Easier ways, if you do hand workout, I think we will understand better. Correct? So you can just screen capture your answer and put it inside the Google Classroom, which the code I have given, exercises morning. Correct?
Siapa?
Okay.
Okay, sir.
Any questions you would like to ask before we close the Zoom session for today?
Nothing, sir.
Okay. Are you able to follow up with all those things that which I have taught you this morning?
Yeah.
Okay, so clear. So you will be able to do all the exercises that I gave you just now.
We cannot promise about that, but we will try to.
Yeah, it's easier. You already given examples, right? It's very simple, right? It's smaller mathematics. It's just when we know the mathematics and we know how the process goes, of course, it's easier. You will not take more than 1 hour to complete all the exercises. I hope before we see again in the afternoon, you will be able to complete the answers. I will see. I will look at how many of you have posted before our class in the afternoon. Okay, try your best. Try your best.
Okay.
Whichever you can complete, try to complete lah. Try yourself, because we need to give our CPU enough things to get active. Okay, try your best. Okay.
Okay, sir.
Thank you very much.
Okay, sir.
Okay, thank you very much. Bye bye.
Ya, ya. Wadah.
Bye.
Okay, try to
Thank
exercise.
you. Thank you.
Thank you,
Okay,
sir.
Mana
okay,
motor
see you
lu,
in the
Pak?
afternoon. Okay, see you in the afternoon.
See you.
Okay, see you in the afternoon.
You.
You too, sir.
Kamsahamnida, sir. Please help me. Belum ada iya aja.
you.